Bismillahirrahmanirrahim. I welcome you all into my today lecture. In today's lecture, I will tell you about the Maxwell equations. But here, the Maxwell equation introduction is very short. Okay, rather you can say that it is very basic. The Maxwell equation. The Maxwell equation, actually the equation which the predict the Maxwell equation predicts the, the Maxwell equation predicts the existence of the Maxwell equation predicts existence the existence of electromagnetic waves of electromagnetic electromagnetic waves and that such waves are accelerated that such waves are accelerated that such waves are radiated by the accelerated charges. So if you remember in the first chapter I told you that when the charge is at rest there is electric field around it. As you see for a charge here, there is electric field around it. Okay, when the charges are accelerated, then there is when the charges moves with a constant speed, right, moving charges constitutes magnetic field around it. This is what you have done in the previous chapter also. Now when the charges are accelerated either by magnitude or by direction, then there is electromagnetic waves radiated in that vicinity. So this concept was explained by the Maxwell equation. Here we are just doing two important things for this reason. In the Maxwell equation, here we will find out that the changing magnetic field, the changing magnetic field produces electric field. This is part one. The second part of this is the changing electric field. The changing electric field produces magnetic field. And here I will explain these two to you one by one. Now let us see, for example, if we have the magnetic field for the first part, the changing magnetic field produces electric field. Here I will explain this to you. Let us consider that we have the magnetic field. Let me say this is the magnetic field. This is the magnetic field. Okay, the magnetic field is changing, changing magnetic field delta V. If we have the conductor, let us see that we have the conductor like this one. This is conductor. The magnetic field is changing across this conductor. Let this is be the radius r of the loop the conductor forms, and if the conductor moves across the magnetic field, the changing magnetic field such that there is induced EMF in the conductor, that is I. Okay, then we will start from the Faraday law according to the Faraday law, according to the Faraday law. Now, Faraday law states that the induced EMF produced is directly proportional to the rate of change of magnetic flux delta T, or we can write that the induced EMF is the changing magnetic flux delta BA, right? That is the changing magnetic flux. Now, as we know that the potential difference, this potential difference is always due to electric field, right? If there is potential difference, so potential difference is what? Potential difference, potential difference is always due to the electric field, always due to the electric field, means that the electric field will be generated at each point of the loop. So by symmetry, we say that the electric field intensity is in the direction of the, and that is the electric field, and that is there must be what? There must be the electric field intensity or the electric field established at every point inside the conductor. So now let's see that if we have the charge particle right now, for example, and if it start moving from the point A, and if the charge particle has to move back to the point A, then the amount of work done while moving the charge particle from the point A will be what? It will be the force into displacement. Now, which force? The electrostatic force. Why? Because we know that electric field intensity is the electrostatic force per unit and charge. So what does this mean? That this electrostatic force is equal to Q into E. Now you know that this this electrostatic force, this work done will be equal to the electrostatic force per unit charge into the work done while moving the charge around the circular path, and that path is 2 pi r. Right now this work done will be equal to 2 pi r into the charge. Now what is that? The force Q into E. This is equation number 1, and this is equation number 2. Also, from the definition of the electric potential, that it is the work done per unit charge. So what does this means? That it will be equal to 2 pi r QE into Q, which will, this will get cancelled, and you have the equation 2 pi r into the electric field intensity. Now from this is equation number 3. From equation 1 and equation 3, we can write that the electric field intensity 2 pi r e equals the delta by delta t into delta b into a. Now since a is constant, so let this will be taken out a, and it will be 2 pi r into delta b by delta a. Now this equation, if you see in this equation, this is in fact what? It is the rate of change of what? Rate of change of magnetic flux. Magnetic flux. So these equations tell you the electric field intensity A 2 by R into delta B by delta T. So here you see that the changing magnetic flux is the cause of electric field. It is the cause of E field. Clear? So the changing magnetic flux always produces, it always produces the uh, electric field, or it establishes electric field in the nearby coil. The second point here, point 2, now contrary to this, the electric field intensity, that is the second point, that the changing electric field, the changing electric field, the changing electric field produces, it produces the magnetic field in the nearby region, magnetic field. For this purpose, let us, for example, consider that we have this kind of arrangement. As you see here, we have the electric field here. As you see, this is the electric field, this is potential, this is the potential difference, plus minus, this is our electric field. As you see, look, the electric field intensity, a constant electric field between the plate A and the plate B. Now here the this is just like, if you see that this situation acts like a capacitor, right, where the medium is air. So the charge Q on the capacitor of capacitance C having area A, which is separated by distance D and potential difference V, we can simply write as from the capacitance equation. The capacitance equation, we can write that Q is equal C into V. And you already know from the first unit that the capacitance of the capacitor is this into V. And you know that if this is, if the separation between the plates is D and the potential difference is V, then we know that V equals E into D. So here this will be E into D. So Q is equal for the charge stored epsilon naught A E. This is equation number 1. Now, as from the, by the definition of the changing current, by the definition of electric current, we know that electric current is what? That electric current I is the rate of flow of charges delta T. So look, from dividing equation 1, like R by delta T, delta Q by delta T equals delta into delta T, and the Q is equal to, this Q is equal to epsilon naught A into E. right? And here you see that delta Q by delta T equals A, since area is constant, area of the plate is constant, and there is the, sorry, not this area. This will be taken outside and I'll be writing it like A dot E into delta T. Now you see that this delta Q by delta T equals A into, this is equal to epsilon naught into delta psi into E. Now you know that this is what, this is the electric flux E dot A, and this is delta T. So here you see that the current I equals the epsilon naught times into the rate of change of electric flux or electric field, this delta T. Now here, look, here you see that the changing electric flux produces what? Changing electric flux. Changing electric flux produces electric current or establish electric current, as you see this. But we know that from one of the most famous important equation, or you can even say from the Ampere law, that there is always magnetic field. There is always magnetic field associated, magnetic field associated with the moving charges, the moving charges. There is always associated the magnetic field with the moving charges. And this is what? This is in fact the moving, this is in fact the moving charges. Look, current is, you just see, it is this thing. Clear? So when there is a current, then what? There will be a magnetic field. So this indirectly extend our concept to the point that the changing magnetic field, the changing electric field is the cause of changing magnetic flux, changing magnetic flux, or the cause of the is the cause of the magnetic field side. Magnetic field. Yeah, so this is what it explains, and from this point we can easily find out that this changing electric and magnetic field, magnetic field magnetic field, this is the result, causes electromagnetic waves in the nearby region. Electromagnetic waves, right? That is, so whenever the charges are accelerated, that is whenever the charges are accelerated, whenever the charges are accelerated, they produce electromagnetic field. Whenever the charges are accelerated, they produced electromagnetic waves in the nearby region. They produces electromagnetic waves nearby region, the speed of which is the speed of propagation, yeah, the speed of which is given by this C is equal to 1 over mu naught into this one. So, and when this is where this is the mm, permittivity, this is the permittivity of the free space of free space, while this is what, this is the permeability of the free space. This comes from what, the Ampere law, if you remember. Okay, the constant in the Ampere law. So this is the permeability of the free space, and usually the magnetic properties, and this is the electric property. And when you put the values of these two, which you already know, is this one is 8.85 into 10 raised to the power minus 12. I just want to write the numerical value without any units, but just wanted to tell you very important point, and that important point is that it comes out to be nothing but the speed of light. So what does this suggest? This suggests that the EM waves, travel with the speed of light, speed with the speed of light. Conversely, we can say that light is nothing but consists of electric and magnetic field that propagates into space with the speed mentioned above, right? Are the most important summary, I would like to tell you that the the whenever whenever the electric whenever the electric or magnetic field varies in time, magnetic field varies in time, if it varies in time, the other field is induced in space. The other field is induced in space, and the result is electromagnetic waves. electromagnetic Electromagnetic waves. That is the result. That is, so the changing, that is, the accelerated charge always produce electromagnetic waves. And the electromagnetic waves, when as I told you that the accelerated charges produces the electromagnetic waves, so electromagnetic waves are EM family, is not just consist of one type of waves, but EM family. The entire EM family consists of infrared waves, infrared. You got a little bit introduction in the previous classes, maybe, right? And about their application, the infrareds, the microwaves, the radio waves, the ultraviolet waves, ultra, the ultraviolet waves. Similarly, it consists of the X-rays and gamma and gamma rays. They are all in the order of increasing the frequency and energy. So you can read this in your book. These are very simple to understand. Okay, so this is the end of your this unit. So inshallah, see you next time. Allah Hafiz. Thank you.